Hello everyone, welcome back for example 3. We're going to be solving equations that contain fractions. Okay, so to do this we're going to solve each equation, we're going to check our answers, and then write that original equation each time. So the first one, A, 5/9 times V equals 35. We're trying to get V by itself. Is V by itself? The answer is no, it is not. Okay, so we want to get V by itself. Right now, when we have 5/9 times V, what this means is 5 times V, and it means that this is being divided by 9. So if we want to do the inverse of 5 times V, we would actually divide by 5. And if we want to do the inverse operation of divided by 9, the inverse operation of divided by 9 would be multiplying by 9. So whenever there's a fraction right here, I just like to multiply by the reciprocal. A reciprocal is when you have a fraction and then you just flip it. So 5/9 and 9/5, they're reciprocals of each other. So whenever I see a variable multiplied by a fraction, I just multiply it by the reciprocal to both sides, like this. Now it's really cool because whenever you multiply fractions, you look to see if you can cross cancel. So 5 goes into both of those, 5 goes in there one time, 5 goes in there one time. 9 goes into both of these, 9 goes in there one time, 9 goes in there one time, and basically you have 1 times 1 times 1 times 1, which is all 1. 1 times V is V. Boom, V is now by itself. So it's a really easy way to get V by itself when there's a fraction, to always multiply by the reciprocal. So let's go over here to this fraction. 35 over 1 is the same thing as 35. So whenever we're multiplying, we always look to cross cancel first. So 1 and 9, there's a 1, so there's nothing really we can cancel it out. 1 is already to its lowest component there. But what about 5 and 35? Is there a number that can go into both of those? Yeah, 5 can. 5 can go into 35 7 times, and 5 goes into 5 1 time, and then we just multiply across. So 7 times 9 is 63 over 1 times 1, which is just 1. So we end up with V equals 63. All right, now it's time to check it. So we're going to check it. We're going to go ahead and write that original equation, which is 5/9 V equals 35. And then we're going to substitute 63 in for V. Okay, and really we're going to make 63 a fraction, 63 over 1. And here we are multiplying fractions again. So we want to look to cross cancel first. There's nothing we can do with that 1 and 5, but what about 9 and 63? Yeah, 9 goes into both of those. 9 goes into 9 1 time, and 9 goes into 63 7 times. So now we just multiply across. 5 times 7 is 35 over 1 times 1 is 1. And 35 divided by 1 is just 35. So this is a true statement, which means our solution that we stuck into this original equation, 63, is the solution to this original equation. All right, so we did it right. Let's go on to B. Okay, so we have 5 over 2 equals 4y over 3. So again, we're trying to isolate that y and get it by itself. But what I see is that it's all being multiplied. Y is being multiplied by 4/3. Even though it's 4y over 3, that is the same thing as 4/3 times y. So really, it's a fraction being multiplied by y. So we're going to just multiply by that reciprocal, which would be 3/4 to both sides. What happens? These 3's cancel out and become 1s. The 4's cancel out and become 1. We're left with y. Then we go over here, we try to look to cross cancel. You can't do anything with the 2 and the 3. You can't really do anything with the 5 and the 4, so you multiply across. 3 times 5 is 15 over 4 times 2 is 8. And you look to put that in lowest terms, and that's pretty much it. So I'm going to use the symmetric property of equality, and there we have it. Y equals 15 over 8. And I'm just going to leave it as that improper fraction. I'm not going to change it to a mixed number. It's just that's going to be my answer. So I'm going to go and try to check this. So I'm going to rewrite that original equation. 5 over 2 equals 4y over 3. And then I'm going to substitute 15 over 8 in for y. And that's going to look like this. For y, and then this is divided by 3. All right, so now we have a complex fraction here. That's okay, we're just going to do one thing at a time. We're just going to look at this top part. So I'm going to take this and go 4 over 1, and then we're going to look to cross cancel. Well, we can't do anything with the 115, but the 4 and the 8, is there a number that goes into both 4 and 8? The answer is yes, 4. 4 goes into 4 one time, and 4 goes into 8 2 times. So now what I have is I have 15 over 2. Well, 1 times 15 is 15, right? And then 1 times 2 is 2, and all of that is being divided by 3. So whenever I have something like this, which is a complex fraction, 15 over 2 divided by 3, I like to kind of go old school and write it like this. 15 over 2 divided by 3 over 1, right? 3 and 3 over 1. And remember, whenever we divide by fractions, that is the same as multiplying by the reciprocal, which would be 1/3. And then we're multiplying fractions again. We looked at cross cancel. Can't do anything with the 1 and the 2, but what about the 15 and the 3? Is there any numbers that go into both of those? Yeah, 3. 3 goes into 3 one time. 3 goes into 15 5 times. And then we multiply across. We get 5 times 1, which is 5, over 2 times 1, which is 2, equals 5 over 2. So that's a true. 5 over 2 is equal to 5 over 2. It's a true statement, which means our solution up here, y equals 15 over 8, is the solution to that equation. Whew, that was a lot of work. All right. So that's how I'd want you to do that check. All right, so let's go on to C. C, we have negative 1/4 equals 1/5 b. So we're trying to isolate that b, get that b by itself, right? So right now it's being multiplied by 1/5. So let's go ahead and do the inverse, which would be to multiply it by its reciprocal, which would be 5 over 1 to both sides. When there's a negative, I like to just put that in parentheses so it's obvious that this is being multiplied. Okay, 5 over 1 times 1/5, that's all going to cancel. That's going to be 1. 1 times b is just b. And then we look over here, we're multiplying fractions again. We look to cross cancel. There's nothing we can do, so we multiply across. 5 times negative 1 would be negative 5 over 1 times 4 would be 4. So we're just going to leave our answer like that. B equals negative 5 over 4. Okay, so let's go ahead and check it and see if it's right. Write the word check. I'm going to write that original equation. Negative 1/4 equals 1/5 b. Okay, so we're going to substitute this in for b. Negative 1/4 equals 1/5 times negative 5/4. Right? Okay, so we're going to simplify this. We're multiplying fractions, so we look to cross cancel. There's a common factor of 5 here. 5 goes into 5 one time. 5 goes into 5 one time. We can't do anything here. I'm just going to rewrite this. So now we can multiply across. So 1 times 1, or 1 times negative 1, is just going to be negative 1 over 1 times 4 is 4. And there we have it. Negative 1/4 is equal to negative 1/4. So this is a true statement, which means our answer B equals negative 5/4 is the solution to that original equation. Okay, on to the last one, D. Okay, we have 4/6j, or 4j divided by 6 is equal to 2/3, or 4j over 6. We want to try to get j by itself. And whenever we have this, like this, 4j over 6, remember that's the same thing as 4/6 times j. It's the same thing as this. They mean the same. You can write them. Those mean the same thing. Okay, so we're going to think about it like this, 4/6 times j, and think of it as a fraction, and we're just going to multiply by the reciprocal, which would be 6/4 to both sides. Okay, we're multiplying fractions. We look to cross cancel. There's common factors here. They become 1. 1 times all of that is 1 times 1 is just 1. 1 times j is j. Equals, now we're going to look to cross cancel over here. What's a common factor between 2 and 4? 2. 2 goes into 2 1 time. 2 goes into 4 2 times. What's the common factor between 3 and 6? 3. 3 goes into 3 1 time. 3 goes into 6 2 times. And then we multiply across. 1 times 2 is 2. And 1 times 2 is 2. And then we can simplify further, right? Because 2 divided by 2 is just 1. Okay? Now let's go ahead and check and see how we do. So we're going to write that original equation, 4j over 6 equals 2/3. We're going to substitute 1 in for j. So we're going to have 4 times 1 over 6 equals 2/3. Okay, 4 times 1 is just 4, so 4 6 equals 2/3. Now we're just going to look at 4 6. Can we put that in simplest form? Is it in simplest form? Or is there a number that goes into both 4 and 6? Well, they're even, so we know that 2 goes into both of those. 2 goes into 4 2 times. 2 goes into 6 3 times. So we actually end up with 2/3 equaling 2/3, which is our true statement, which means our answer, j equals 1, is the solution to that original equation. All right, awesome work. We will see you back for example 4.